Assalamualaikum Bu Santi, kedengaran suara saya dari sini?
Waalaikumsalam warahmatullahi wabarakatuh. Kedengeran, San?
Oke, Bu boleh nyalain. Nah, bentar ya Bu, tunggu sebentar.
Mohon enggak. Pak Syawal jadi peserta juga nih?
Iya.
Apa jadi instruktur?
Peserta dulu.
Masya Allah.
Dia mau nambahin dari Sanny.
Dari satu event ke event yang lain ya, Pak?
Selamat datang untuk teman-teman partisipan yang online. Apakah sudah pada makan siang? Kalau yang di offline sudah pada makan siang, Pak, Bu. Jadi diharapkan membuat snacknya masing-masing ya untuk yang online.
Baterainya itu.
Kegiatan ini akan segera dimulai, tapi masih menunggu dari speaker pertama dari Nia dari Bangor University-nya. Jadi diharapkan buat teman-teman yang lain, partisipan online yang lain, bisa menunggu dan menyiapkan settingan komputernya dulu. Alangkah baiknya sudah membuka Python-nya, software Python-nya, dan pendukung terkait kayak chargeran juga lebih baik sudah disiapkan dari sekarang. Terima kasih. Partisipan online tolong diganti namanya dengan dari mana instansinya, lalu underscore pakai nama. Ragamkan dan nanti kedepannya juga kalau misalnya akan ada tanya jawab bisa lebih mudah dalam pengenalan identitas. Terima kasih. Dari teman-teman offline atau offline kayaknya udah pada semuanya orang Indonesia ya. Kalau untuk yang partisipan online, apakah ada yang berasal dari luar Indonesia? Jadi nanti sebelum ada speaker dari pembicara pertamanya Nia Jones dari Inggris. Jadi kita bisa pakai bahasa Indonesia dulu gitu sebelum memulai. Sudah? Hai Nia.
Oh.
Hello. Good morning or good afternoon, everyone.
Good afternoon from Indonesia. Okay, first of all, good afternoon. Welcome for all participants. My name is Sanny Utami, and today I will be the moderator for this workshop. this workshop is about academic knowledge exchange about marine debris modeling software using OceanParcels in Python. And this workshop is as a part of International Conference for Fisheries and Marine Sustainability, or ICOFIMS. This is like a collaboration between Universitas Padjadjaran and Bangor University. First of all, before we start this workshop with Mia Jones, opening remarks will be delivered from Santi. Santi Anggraeni, she is head of Research Center of Maritime Studies Padjadjaran University. Okay, please, Santi, time is yours.
Thank you very much, Sanny, for the opening speech, and welcome to. How can I call you, Nia? Nia, is it okay? Yeah. So thank you very much for sharing with us about this new. I think this is a new software, yeah, for the modeling of especially plastic pollution in the ocean. So dear all participants, thank you very much for your participation in this I think it will be a very nice and very interesting workshop and also a training. So I hope all of you will have a, how it's called, fruitful result, and also you can learn not only new software, but also you can gain a new network during the event. So what I want to say that especially I appreciate for your interest to learn these new things, and I hope it is not only because you need it for your study or for your career, but also because you also very concerned about our Earth sustainability, since even though there's a global program launched by the United Nations regarding the Sustainable Development Goals, but unfortunately we still can see that the achievement of the goals, especially the goals for halt or for stop the earth pollution, especially marine pollution from the plastics, still happens everywhere, and it's quite alarming. So therefore, I hope after learning these new skills, you can contribute positively and actively using the skills to improve our knowledge, and also our how it's called. We can say that hopefully these tools also can be a new tools for early mitigation, how we can detect the pollution without delaying, since at the moment it's very difficult to detect the pollutions what's called in situ, yeah, or directly when the pollution is happen. So I think that's all my remarks for the opening speech. And once again, I would like to say congratulations for the event organizer, and also thank you very much once again to Nia Jonas and also the Bangor University, who are willingly and kindly share their knowledge and also their expertise to us. And hopefully this collaboration will be developed further in the future. Enjoy this event, and I hope all of you will get a new network, new skills, and new environment. Thank you very much.
Yeah.
So, Sanny, you're muted.
Okay. Now, before we start our workshop with Nia, I think we should to tell you from committee about the rules. Please share the rules.
Ini.
Okay. For this workshop, around 100 people who have been applied this workshop. Oh, yeah. This is the distribution of the participants who join this hour's workshop today. The number of offline participants is around 17 participants, and the number of online participants is around 30 participants. And the distribution between male and female, 31 for male and 70 female. And for online participants, the distribution mostly come from Java Island. But when I see the name in the Zoom room, the participants also come from several universities in Indonesia. Okay, next slide. And the activity runner for today. Today, Nia will lead the introduction about software, about the Python, and introduction about software OceanParcels. And after that, we will continue with the second speaker. He is Mr. Kemaal. Mr. Kemaal will tell about parameter oceanography data in Indonesia. Mr. Kemaal will give some information about parameter oceanography data. And the last thing, yeah, this is the important thing for participants. Please arrive on time. Bring your own laptop and please prepare the charger and already install the software that will be used like Python, Jupyter Notebook, and OceanParcels. And all participants should be disciplined. For offline participants, should be have been vaccinated and in good condition. Wearing your mask during the event and wear an appropriate outfit. And for online participants, please activate your camera during the event. So for now, if you still in off cam, please to open the camera during the event. Please don't activate your audio before allowing by me. And please discipline and do not bother other participants in the room chat. Okay. Oh yeah, and last thing, please rename your name by institution _ your name. Yeah. And Nia, hello, do you hear me? Please,
Yes, yeah, I can hear you.
Okay. First speaker is Nia. She is a PhD candidate from Bangor University, and her research focus on mechanism that govern microplastic of system and self-sys, right?
Yes,
And her project, right. It's about the dispersal of microplastic in the marine environment to determine the transferal variability of microplastic and its transport from estuaries to self-sys. Okay, for now, the workshop will lead by you for 60 minutes, and please be slow, talk slowly because we are not native, and yeah, it's still a new thing for us about OceanParcels. So please be slow and talk too slower. Thank you. Okay, Nia.
Great, thank you, Sanny. Good afternoon, everyone. It's morning here in the UK, but afternoon over there in Indonesia. Thank you for the wonderful introduction, and yeah, thank you for all the organisers for organising this all. I think this is going to be a really great and worthwhile event. So I've got a basically my plan for today is to kind of deliver a bit of a lecture on kind of ocean parcels and particle tracking, which is the type of model in general, and then do a kind of like live coding session just to introduce you to Python coding and Jupyter Notebook, which is the kind of thing we'll be using. So I'll first share my screen and then we can get into that in general. But like Sanny said, if I'm talking too quickly, if I'm saying anything that you don't understand, please just either raise your hand or shout out. I really don't mind. I won't find it rude. Just ask any questions. So if I just share my screen. Great. So can you see my presentation? Yes. Is it in presentation mode? Just need to check. Yeah. Great. Okay. So so thank you very much for kind of inviting me to present today in the kind of academic knowledge exchange. And yeah, thanks to both universities and kind of the British Council as well for funding it. So today, kind of in this lecture, we'll go over kind of me, who I am, why am I teaching you this today, kind of ocean parcels and kind of the software introduction and what you need to use ocean parcels, kind of different test cases or different case studies of ocean parcels, kind of examples of what you can use the software for. And then also kind of the next steps, what we'll do next and what we can do tomorrow. Okay, so it's very nice to meet you all. It's great to see so many people kind of online and in person there in the classroom. So like Sanny said, my name is Nia. I'm a PhD student at Bangor University, which is in Wales in UK. And my PhD is on the physical oceanography of microplastic. So I look at how microplastic moves kind of around our coast and what physical processes kind of influence that movement. I've got a little bit of experience with ocean parcels through kind of simulating the dispersal of plastic pollution in kind of different environments. So kind of around the Irish Sea, which is a kind of regional sea here in the UK, and also around Sulawesi Island, which is kind of a part of this project, part of this knowledge exchange. So a couple of ways of using it. I'm still very much a beginner, so I can learn with you, and it's kind of all part of the learning process as well. So yeah, like I said before, if you don't understand anything or if you have a question, just please raise your hand or use the chat, whatever's easiest. And if for some reason I haven't noticed, just shout at me and I'll be able to listen. You can contact me kind of on email or through Twitter after the workshop if you have any questions, and my LinkedIn is there as well. So those are kind of the different ways you can contact me. So the first thing we'll go through is kind of a introduction to modeling and particle tracking and the ocean parcel software. So ocean modeling, oh no, that's not, why has that got noise on? I could do a whole kind of hour and a half lecture on ocean modeling and kind of the different kind of nuances and different things behind it. But there's kind of just some main things you need to kind of understand when using an ocean model for kind of the use that we'll do it today. And you'll need to understand that an ocean model is just basically a representation kind of in computer code describing kind of the different physical processes in our ocean, which help us understand kind of how the ocean works. What you'll get from kind of the ocean models today is kind of a series of current speeds, which will help us kind of guide that plastic through the ocean. So this is kind of the underlying basis of what we need today. So in general, there's a kind of few ingredients. We need to make an ocean model, and those are things called the primitive hydrostatic equations. So those are kind of the 7 main equations that govern the water in the ocean. And at this stage, you don't need to know what they are. You just need to appreciate that those kind of are quite important, and they kind of include things like the conservation of heat and the conservation of energy. For example, you can't destroy energy, you kind of need to be conserved. You've then got some boundary conditions, and kind of in the model that would include kind of any kind of atmospheric kind of forcing or kind of river input or that kind of thing. Then you have any initial conditions, so you can set up kind of the initial temperature and initial depths. This allows you to run your model a little bit quicker and it get up to speed a bit quicker. And then you've got forcing fields as well. So all of this is just kind of a just for you to appreciate that kind of what goes into the wider ocean models and kind of the results files that you'll be working with today. So once you've got your ocean model, that can then go into a particle tracking model. So particle tracking is usually used in physical oceanography and limnology, which is kind of the studies of both the ocean and kind of freshwater environments. And it studies kind of the transport and mixing of kind of tracer substances by either observed or modeled flows. So you can use either ocean models like we just talked about, or you can kind of observe, make some observations in the ocean and kind of go from there. So again, this is just for kind of your general information, but it's generally organized. Ocean models are generally kind of organized into 2 groups. They're categorized, and that normally is into Lagrangian particle tracking models. And that deals with kind of individual particles, and that calculates basically the trajectory of each particle. So you can see where the particle is going for each model. Another type of particle tracking model is something called Eulerian. And this deals with kind of the concentration of particles, and kind of it calculates the overall diffusion and convection. And that kind of works with kind of water quality and kind of different pollutants. But today we'll be dealing with Lagrangian, and we'll be kind of tracking individual bits of plastic throughout the ocean. And that makes it more visual as well. It's nicer to see, I think, Lagrangian models. And it's important to appreciate that particle tracking models vary in complexity. So it kind of depends on what you want to look at and what you want to study. You can have different complexities of model. We'll be using quite a simple version of OceanParcels today. We'll be using just the surface water. We'll be doing it over a short space of time, and we'll be assuming some things about the plastic, like they'll be buoyant on top of the water and they won't be sinking. Now that of course isn't particularly realistic when you're dealing with long time scales, but it is quite good for kind of short time scales which we can model. When you want to get a little bit more complicated, and if you're looking at the kind of the literature and the different studies online, you'll see that some particle tracking models start to include a lot of different things. So they'll include kind of things like particle density, kind of sinking velocities, and kind of really start to attach different information to the plastic to be able to affect how it's moving through the water. Is everyone okay so far? If everyone got any questions and everyone can hear me okay?
Yeah.
Yes? Great, okay.
In English, in Indonesian, sorry.
Great, okay, just checking that I'm not talking and no one can hear me.
Okay. For offline participants, do you have any question? I think online participants, Untuk yang online partisipan udah ada yang sudah mulai mau ditanyakan atau mau dilanjutkan dulu?
Belum, lanjut.
Lanjut dulu. Oke. Yes, Nia, you can continue.
Okay, great. Okay, so like I said, there are lots of different ocean. Great, no, not yet, no questions. Great. So there are lots of different particle tracking models. Just one of them is OceanParcels. And the OceanParcels develops the model, which is Parcels, which stands for probably a really computationally efficient Lagrangian simulator. So you've got this word in here there, Lagrangian, and that's just the type of particle tracking model that it's using. So this model, OceanParcels, is actually just a collection of classes in the programming language Python. And you can customize the model to create simulations from ocean circulation models. Like I said before, Parcels uses the Lagrangian particle tracking method, and Parcels is written in Python. Now, I don't know how much experience everyone here has with Python. Do you learn Python, or is it kind of completely new? Or is there probably a mix? Okay, I'll just explain it then in terms of if you don't know much about Python and don't know much about the different processes. Oh wait, learn Python is a mix. Great. Okay. So Python is best accessed, I think. So OceanParcels is best accessed through something called Jupyter Notebook, which is a platform which can combine kind of live code, narrative text that can kind of tell you different instructions and different visualizations. So this allows Jupyter Notebook to be really, really flexible and a really great way to start learning Python. So I'll take you through a bit of that later today, and kind of do some live coding with you before we start the more kind of OceanParcels particle tracking side tomorrow. The best way to get Jupyter Notebook kind of on your own machine is through something called Anaconda, which you should, I think there's a document that comes with this workshop on how to download this through your own machine. And all of this is kind of free and open access to use. So OceanParcels, Anaconda and Python don't need to pay, you just kind of need to download it from the official websites. So with the parcel structure, now I'm going to go through kind of the different parts of OceanParcels now, and it's going to feel like a lot of information, but if you don't understand, don't worry. We'll just I think it's just easier to go through everything and you kind of have an idea of what to expect, and then we can start practicing it tomorrow. So I like to explain that Parcels has a structure like it's built in different layers. So the first layer is something called the field set, and this is basically where all the hydrodynamic data is kind of stored. The kernel is basically then how it runs, how Jupyter Notebooks accesses Python. And don't worry, I've got slides after this that goes into each of these in more detail. The particle set, so all of these, the field set, the particle set, and the particle file are all terms used by OceanParcels. The particle set is the kind of information in the model about the particles themselves. So this is kind of all the initial particle information. So how many pieces of plastic you want, how often are you releasing them, where are you releasing them, kind of all that information will be held in the particle set. Then when the model is running, it kind of iterates over itself. So it starts going in a circle and starts going through the different time steps and updating the location of the particles. So you can then go through as many time steps as you want, and all while that is happening, it's writing results to a particle file, which is basically a results file. And there you can start to kind of get the information out and start to post-process or kind of the results you've had from your model. That's when the really exciting stuff starts, I think, because you kind of see all your results. Right. So like I said, I'll go back through all of those different layers, and it hopefully should explain things a little bit more. So the field set, like I said, is the main place where the hydrodynamic data is stored, and that's called, that is where the zonal and meridional velocities are stored. Sorry, I misspelled meridional there. So all of this data, all of the kind of data of the speed of the ocean and how quick the currents go are stored in the field set. So this data, usually it can come from observations, but usually this comes from ocean models, which describe the physical and thermodynamical processes in the ocean. So there are loads and loads of different ocean models available, all of which have different types of grids. They have different resolutions and time frames. So you've got models that are specifically designed to be very high resolution and kind of start to resolve coastlines very well, or you've got much larger grids with a low resolution, and they can start to model kind of the global circulation much better and kind of the heat transfer between our different oceans. So it kind of depends on what you want, really, kind of what model you choose. But the model we'll be using in this workshop is called HYCOM. And this model is kind of free and open access, and you can download this if you want and kind of have a look at the data. But today or tomorrow, so you'll be given the files you need, the necessary files, the ones, and it's cropped around Indonesia, the model. So that then kind of controls the file size and makes the model a lot easier to run. So then the next layer is the particle set. So like I said, this is where all the information of the particles are being stored. So this can kind of set up and store all that information. It has different ways of setting it up. So it has different constructors, is just the word it uses. And this allows you to set up and release the particles in kind of lots of different ways. So you can, for example, so these are here. So these are all different things that you can put into the code itself. And this allows you to release the particles in different patterns. So you can release them from a line. So you can kind of simply draw a line and then release them from that line, kind of that they'll be equidistant on that line. You can release them from a particular list with particular locations, and that allows you to be really specific. So say you know there's plastic coming from this particular river, you can release them from that river. From particle file, so this allows you actually to release particles from locations that they ended up in another results file. And this allows you to kind of run big models in chunks, and you can kind of carry on with your simulations quite easily. And then from fields, and this is just another type of release pattern that kind of disperses them evenly across your grid. You can also choose how often to kind of repeat the release of these particles. And this allows for kind of a very realistic simulation of how plastic actually releases into the environment. Because when you think about it, all the plastic in the ocean at the moment wasn't just released in one go. The kind of one of the main sources of plastic into our ocean are rivers. And that is releasing plastic pollution, kind of a certain amount of pieces per hour, per day, per week. And you can kind of start to control that in the model as well. and that can then influence the movement going forward. So the next layer is the particle file. So this is the results file. And so as the model is running, the results will get written to this file. And this file is something called a netcdf file. If you're not aware of this type of file type, this is quite a common file type in kind of environmental sciences. It allows for lots of different types of data with different dimensions to be stored in the same file. So it's quite a useful data, quite a useful file type to get used to. So the data is stored in a two-dimensional array. So it's kind of just basically a grid where each particle is stored as a time series. And that means each particle has its own row. So then you can kind of get the time series from that easily. The file structure can be a bit tricky to get your head around, and we'll go through kind of post-processing and plotting the file tomorrow. Because like I said, it takes a bit of explaining, but more information can be found online on the file structure, and as well it'll be explained in greater detail in kind of the interactive code exercise that you'll be given. Right, so those are kind of the main building blocks, I would say, of kind of modeling in OceanParcels and kind of what you need. So you need an ocean model, you need to build a field set with the hydrodynamic data, and then you need to kind of then you need to initialize any information to do with the particles, and then you can run the model. So that's a very simple explanation of how the model runs. But to give you a bit of an idea of kind of what the output looks like and how the model can be used, I've kind of put together a few kind of outputs, a few test cases of different projects that different people have done with OceanParcels to kind of give you a better appreciation of how it's used. So any questions so far before I move on?
Mungkin saya.
Oh, okay.
Okay. Thank you very much, Nia, for your explanation. Here, maybe I have a question about the utilize this software related what you said before, that this software can figure out the moving of particle in the surface water, right? How about is it possible if this software can figure out about the water mass itself, like wave propagation or current or water runoff? Is it possible or not? Okay. That's my question. Thank you very much.
Okay, great, good question. And I think it's quite difficult to hear, but I think you were hearing about, I think you were asking about whether the model can model kind of the water itself and kind of the wave propagation. This is actually not the model to do that. It doesn't actually deal with the kind of dynamics of the water. You'd have to use a different model for that. So there are a few, especially if you want to concentrate on waves, the modeling of waves can be quite difficult. But this model is to simply kind of track matter in the water. I hope that answers your question.
Thank you.
Great. So if there are no more questions, I'll plow ahead with the test cases. Right, so this output is an output from a master's student here at Bangor University, Stephanie Barton, who was studying here last year. And this is using OceanParcels, and this will be quite similar to the. Oh, sorry, there's another question in the chat. Hang on. It says, so Farah asks, could parcels be used for backward and forward particles? Yes, so you can run the model forward in time and disperse the particles that way, but you can also rewind the particles. And that happens in the particle set itself. You can kind of rewind time. And this is a really useful function, because say you know that there's a high concentration of particles 3 kilometers off the coast, say, you can then say I want to rewind time and see where those parcels have likely come from. So yes, you can do that. Great question. And then there's another question. Is it possible to model other objects, for example, ships and marine debris in parcels? So you can, so it's not just kind of microplastic or not just plastic pollution. Basically, OceanParcels is just modeling kind of a parcel of water moving through the ocean, and then you can apply different forcings on that and different kind of things to do with its density and that kind of thing. I'm not actually sure whether you could model ships, whether you could model something that big. I'd have to check, but in theory, if you get the density and kind of the movement right, then that'll probably be fine. And because you can also add particular movement to the parcels if you want, and I'll show you in an example, but you can model fish, for example, and how they swim. And so that's quite an interesting application of the model. Great, thanks for the questions. Okay, so back to this. So this is a output of a model that was run by a master's student here in Bangor University, Stephanie Barton. And this is very similar to the output that you'll probably get in the next couple of days of your model. So this is of the Irish Sea here in the UK. I don't know if you can see my mouse, but I live here on Anglesey on the island, just above Wales. And here you can see the particles being released just from one river and then being affected by kind of the currents. So you can see here it gets trapped in an eddy just off the coast, and then also starts to kind of fluctuate with the tide going in and out, and then eventually reaches Isle of Man. So you can really start to see here the influence of kind of plastic pollution and marine debris on kind of the local area. I think it was 100,000 particles were released. So you can really start to see when lots of particles are being released, they really start to accumulate in different areas. So like I said, this was a kind of simple run of the model in terms of it was using just the surface water. It was not putting any other movement on the particles. And this is very similar to what you'll be learning to do in the next couple of days. And then if you're interested, you can kind of go further and make things a little bit more complicated. But this here is a kind of small scale model of this is very regional. Like I said, this is just a small part of the UK. You can also use this model on a much bigger scale, for example, on a global scale. So this is modeling done by a PhD student called Victor Onik. And this is modeling the release of plastic from different parts of the coastline globally, so all across the world. And the blue particles here are particles that are active in the water column, so are currently kind of floating in the water. And the red dots around the coastline are particles that have beached. And so kind of washed up onto the coast and are stuck there. This is a really kind of important bit of plastic movement. Beaching is quite hard to parameterize in a model, so the fact that I can do this is quite good, really. I think I'll just rewind this a little bit. What's really interesting here, I think, is that you've got these kind of large collections of kind of microplastic and marine debris in kind of the major gyres of the ocean, and you can start to see where really kind of high risk areas are for plastic pollution. So here kind of around Indonesia, kind of where there are lots of kind of island nations and kind of enclosed seas, you can start to see where the plastic really starts to get trapped. And it's perhaps more at risk than somewhere like the UK or America, where they can just export their plastic and probably it ends up getting exported to kind of Southeast Asia, probably. So yeah, so I'll just rewind this again. And yeah, you're then starting to see kind of the different, how the different physical processes and the different kind of connectivity within the ocean is affecting is the blue color yes. So the blue particles are the plastic. So the more intense the blue color, the more plastic particles there are in that region. So I thought that was a really great kind of visualization of how you can model plastic on a global scale using OceanParcels. Oh wait, I'm stuck on this thing. Hang on. There we go. So the next example is in New Zealand. And here, basically, I just want to say how different ocean models can also affect the particle dispersal and how you can start to find out more about ocean models with particle tracking. So it's not just about finding out about plastic pollution. You can also kind of rewind and look at the data that you're getting. So this is basically comparing different ways of setting up the model. This is basically comparing different ways of setting up the model and kind of how slippy the coastlines are. Because a known problem within particle tracking and ocean modeling is that if your model is too coarse and if there's too much of a gap between the land and the ocean, where kind of the water starts, your particles can actually get stuck, like on the left here. So lots of particles are getting stuck kind of on the coastline, and it's not kind of recreating that realistic kind of flush out to the ocean of the plastic particles, whereas kind of the modeling on the right here is doing that. This is actually a thing that you have to be careful of in OceanParcels and kind of using the data that we give you. If you're finding that you're running the model and the particles aren't moving, it might be because you've put the release point and the source point too close to the land, and it's not, and the kind of the ocean model values kind of aren't picking up that particle. So we've got another question here. Isn't plastic data? So we're not sure about how much plastic there is in the ocean. How do we get an exact amount of plastic? This is a really good question because we don't actually know. Yeah, you're correct. We don't know how much plastic there is in the ocean, and it's very hard to kind of calculate that. When you're doing modeling like this, you usually kind of either make an informed guess, an educated guess in terms of how much you know are coming from local rivers, for example, or there's another method where you can basically model the extremes. So you say, right, this is a load of plastic. This is the worst case scenario of how much plastic could be going into the ocean. And this is what happens. And this is the best case scenario. And then what's likely happening is something in the middle. So you can then have a guess at where that is happening. but there's a lot of research going on at the moment about how much plastic is going into the ocean and kind of where that's ending up, and kind of whether there's considered kind of a missing budget of plastic in terms of how much we see on the surface and how much we're releasing kind of into the ocean, that those don't add up. There's not as much on the surface as we're releasing, so it must be going somewhere, and we think it's probably going kind of to the bottom of the ocean, which is obviously very hard to measure. So yeah, quite often you have to make a bit of an educated guess and kind of say what kind of errors and what kind of assumptions you're making in your model, which isn't perfect, but it kind of is part of the modeling process. So this one now, like I said, models vary in complexity, and this is actually quite a complex one. Hang on. Yeah, so this is quite a complex one. It's actually not to do with plastic. So like I said, you don't particularly have to model plastic pollution in ocean parcels. It can be other types of particles and other types of parcels of water. So here, the research team on this one, I found this on Twitter. The research team were modeling the behavior of tuna, a type of fish, and this is the tuna is the yellow dots, the yellow particles. The behavior of tuna in relation to attraction devices, which is a type of kind of fishing method. And so if I play this here, you can see kind of within this box, you've got prey in the background, and they're responding to that, and they're swimming around. Then they're also being attracted to these devices. And so this was all done on ocean parcels. And like I said, this is a very complex model because you're dealing with something called particle-particle interaction. So how particles react with each other and how they react within different kind of radiuses. So there's no need to kind of fully understand this at this point, but kind of appreciate that you can get a lot more complex if you want. So how much time do I have left before the next speaker?
I think it's okay for 60 minutes. 60 minutes.
15?
60.
60, another hour?
Yeah.
Great, okay. Great, okay. So we'll just go through the next couple of slides, and then I can show you a little bit of Jupyter notebooks, and then maybe have a break after that. So like I said before, we'll be using Jupyter notebooks to run ocean parcels, and so this is kind of the environment that you'll be working in. And this is just useful to kind of see it before we get into it. So you can install Jupyter notebooks through Anaconda, like I said before, and this installs both Python 3 and Jupyter notebooks. And this kind of package also is commonly used within kind of data science and machine learning. And so it's kind of very useful to start getting used to. So these Jupyter notebook files, or notebooks as they're called, are actually stored as .ipynb files. And this is simply just a text file in a particular format, and you can kind of only open it in Jupyter notebook. So the two major terms that you should understand to be able to kind of appreciate Jupyter notebooks and start using it is a kernel. Hang on. Wonder if I've got. Okay, never mind. I thought I could point somewhere, but so the two major terms that you should understand is a kernel, which is the red box here, and this is basically how Jupyter Notebooks accesses Python. So there are different kernels for different programming languages, but basically when you see kernel, you basically think Python and how the code itself is running. And then Jupyter Notebooks itself is a page that's made out of different cells. So these are basically just containers for text to be displayed or code to be executed. So here at the top, you've kind of got a header cell, which kind of tells you what the notebook is about. You've then got a code cell underneath that, which you can run and kind of get information out of. You've then got different text cells and more code cells. So there's a big mix of things kind of in Jupyter Notebook, and it makes it very nice to kind of lay out and to read, unlike maybe other pieces of code that you've seen. There are loads of beginners guides. There's lots and lots of beginners guides online, either on YouTube or on kind of just online, kind of on different web pages, and yeah, you can find them by just googling Jupyter Notebook beginner's guide. So this next slide is a bit more general, because I think that this is really important to remember when you're kind of modeling and particle tracking, because I think one big thing that when we're learning to code, often we're dealing with syntax, and we're learning syntax, so basically how to type in code, and you know, how to calculate the mean and what code you need for that, for example. That's actually less important. Kind of all that information actually is online in terms of in kind of user guides and that kind of thing. All that information is there for you. What you really need to learn is how to problem solve and how to fix problems in your code. So there's a quote here saying, "The biggest mistake I see new programmers make is focusing on learning syntax and not learning how to solve problems." So I think that's a really good description of kind of why I think it's important to kind of think in kind of a problem solving mindset, because then you'll be able to solve your problems a lot quicker and kind of progress a lot quicker kind of in your modeling journey. So the first thing I think is really important to appreciate is understanding your problem fully. So what line in your code is causing it to fail? What type of problem is it, etc. Kind of where in your code is it failing, and kind of what kind of issue is it. And the kind of first step to understanding that really is an error code. So usually you know your code has gone wrong because it spits out an error code. And this is an example of one here. I've just taken offline. And so here, so while true, print hello world. So while something is true in the code above, print the words hello world. And it says here, syntax error, invalid syntax. So a syntax error, if you just Google the word syntax error Python, it'll tell you why that error's come up. And usually that's like a typing error, like you've got something wrong, you spelled something wrong, or you've gotten something mixed up in how you're typing it. And Python is very useful and very helpful in that it points to the bit where it first realized that there was a problem. So quite often it's either that word or just before. So in this case, there's a colon missing. You've got to put kind of those two little dots after while true. But this is just an example that error messages hold a lot of information, and you can find out a lot of information through these, and not to just see that error message and panic. It's about kind of going back through your code and realizing where that problem arises. And in a similar vein, I think it's important to remember that search engines are your friend, and Google is your friend. So Python and Jupyter Notebook and OceanParcels, like I said before, is actually open access and free to use. not only is that great in the fact that you don't have to pay to use them, but that is also really good because there's a lot of information online, free information that you can access that can help you kind of solve the problems that you're having. If you do get stuck, there are some places which are kind of well known and kind of reliable to get help from. There's a website called Stack Overflow. Again, if you're learning Python already, you probably know all about this. But kind of there's a website called Stack Overflow, and here you can search for questions and ask questions yourself. And usually you get an answer quite quickly. And then you've got kind of the OceanParcels own documentation. So you've got kind of how OceanParcels works, and it's manual basically, and those can be really useful in terms of when you're unsure how to use a function, you can kind of look and see how it's typed and how it works. So that's the end of my lecture. So now let me just stop sharing for a second. So I thought now I would just go through opening Jupyter notebooks with you and kind of do like typing a little bit and figuring out how that works. And then tomorrow we can go on to the actual OceanParcels code and start to get more in depth with that. So I'll just share my screen again, if that's okay. Okay, first, does anyone have any other questions on those last few bits, last few slides? No? Okay. Oh, wait. Oh, yeah. Great. Okay, I don't think anyone has any questions, so I'll just share my screen here. Great. So this is Anaconda, and so this is what you will have or will download to be able to access Jupyter notebooks and Python. And I'll just run through kind of getting a notebook set up and writing on it and all that kind of thing in the next kind of 20 minutes or so. And then you can kind of ask any questions, and then hopefully this will be then a good basis for what we'll do tomorrow in terms of actually running the code. So if I launch Jupyter notebooks, so then a kind of a web thing comes up, and this is all my files on my computer. So then it accesses your file system, and I can just go into documents. And you can go into the different files, and then you can find kind of your different notebooks. So if you remember, I said the .ipymb is the notebook file. And then here, for example, you can make a new notebook or load one up that you'll be using. So you can download the one that we will be using tomorrow as well. And then, so a new Python 3 notebook. And then this page comes up. So this is now a brand new notebook that you'll be able to start writing code on. Like you can see the kernel Python is working, so it's connected to Python here. And I can, for example, rename Nia's notebook. So that's kind of now the title of the notebook. And then you can just start writing some code. So I'll go through some very basic stuff at first to do with Python. Like I said, if you know a little bit of Python, this will probably be very basic, but it just helps with kind of getting everyone up to speed. So in Python, you have to import some modules that you want to use. So for example, if you want to use particular statistical packages, you have to load them and import them into the environment for you to be able to use them. So an example is NumPy, which is a statistical package. So I can say import NumPy as NP, and then I want to import another one, import matplotlib.pyplot as PLT. So this then allows me to work with these packages. And also tomorrow you'll be importing parcels as well. So this is where you kind of import the model to your environment. As with all good code as well, you should comment it. So you comment it with just with kind of a hash and say import modules here. So you can then run each cell individually. So I can click run here, or I can just press shift enter. So I can say run cell, select below, and that's run. So that little star was that it's working, and now that's run. And yeah, so that's kind of the first cell all done. And then I can say, okay, so if I want, I'm going to make up some data here and plot it, so you kind of have an idea of the ins and outs of Jupyter Notebook. So you've got X and Y variables, for example. And then I'm going to put some random numbers in here. This is making just a list of different.
Sorry, Nia.
Yeah.
Make a bigger the window of the Jupyter Notebook, because for offline participants it's really hard to read it.
Oh, okay. I can do this?
I mean full screen. Make it full screen.
Full screen.
Okay, yeah, thank you.
Is that a bit better? Okay, great. Sorry. Yeah, so this is now, so I'm basically making two variables here, X and Y, and I'm just putting some random numbers in. So I've now made X and Y, so I've clicked shift enter, or I can just run this again, and it's given me X and Y. And then I can plot it, I can visualize it, and those visualizations will appear in Jupyter Notebook itself. So I can say PLT scatter. So here I'm using this module, which is kind of the plotting module, one of the plotting modules in Python, and I want to create a scatter plot. And then I can do X, Y, and this is just a very simple, hoping it works. There we go. And then that has output a scatter plot with my random data in. The thing then, like I said, not everyone coding is not about remembering every single bit of your code, but it's just figuring out how to look for the answers. So say that I wanted to make this this plot red. I don't want blue dots, I want red dots. So I can then go say to Google and say matplotlib scatter plot. You won't always get the ones you need straight away, and you can kind of Google different search terms. But what is really helpful is, like I said, the kind of documentation of kind of different models and different bits of code. And I can say this is what we're using here. And I can say, okay, here we go. This is color. So at the moment it's got color none, list of colors or color. And then I can go in and say, right, okay, I want C to be red. And it changes it to red. So there are kind of lots of, like I said, there's lots of information about all these different modules and all these different functions online. And they can be quite tricky to find, and it's not always as, this is a very simple case in terms of changing a color of a plot. But then you can also do kind of some basic stats and obviously more complicated stats. But next I'll use this NumPy, this statistical software, the statistical package. So for example, I can say mean X, so that's the name of the variable, NP. So using NumPy dot mean, so I want the mean of X. And then I want the mean of Y. And then I can print these two. So mean X and mean Y to terminal. Hang on, I've got. So I've got a question here. So this is, so now I've printed the mean of the X and the Y. And this just shows that you can do a lot of lots of different things within the same Jupyter notebook. So you can plot some data, you can read in data, you can plot data, but then you can also kind of analyze the data as well. Like I said, this is an ultra simple case, and I'll go quickly through the things that we'll be using tomorrow. But
Sonia,
yes,
I think your chat window is open, so we cannot clearly your.
Oh,
yeah.
Okay, hang on.
No, the chat room, chat
Yeah.
box, chat box.
I can't quite.
Yeah.
Hang on. There we go. Okay. If I share my screen again.
Okay.
Desktop. There we go. I couldn't click on for some reason I couldn't click on the chat box. So now you can see kind of the whole screen, hopefully. And yeah, so you can have the you basically import the modules, import the data, and kind of plot and analyze the data. And so you can do very basic things and kind of learn Python on Jupyter notebooks like this, or you can do a bit more complicated things like run OceanParcels. So there was a comment just now saying how to bring up the number 1, 2, and 3. I don't know what you mean, which number. So is it if you wanted to print 1, 2, and 3? Is that what you mean?
Sorry for misunderstanding. For one of participant, one.
Can I ask?
Yeah.
Yes, yeah.
Yeah. When I run, my program is error. Was error. I just want to ask, how to show 1, 2, 3, number 1, 2, 3, 4. Can I share screen? I cannot.
Yes, yeah. If you want.
Yeah.
I'll stop sharing mine.
Okay. This is me. This is me.
Right,
yeah. In my screen didn't appear the 1, 2, 3 here, like your screen.
Yeah. Okay. So that is basically.
Yes. And this is error. If I run this error.
Yeah. So in that first box, you've got you've misspelled a couple of things. So you've got import NumPy. So that needs to has an Y on the end. So I'll type it in here. So import NumPy as like this, and then import matplotlib.pyplot as plt, and those go in your first box, and then you can run it. So if I share my screen again, so I can clear, if I clear everything and then clear, so now I haven't run anything yet. And here I can either run one cell by clicking this box here, or I can run all of the cells by clicking here. So this restarts and reruns the whole thing. So if I click this, and that's when everything. So then you can see the 1, 2, 3, 4. If I've then say made a mistake, so say I've accidentally not put the closing square bracket there, I can run everything again, and this will give me an error. So this is saying syntax error. It can't run this line because something's wrong before it, because it's pointed at this Y. So then I can say, oh yeah, I've forgotten to put the closing bracket, put that bracket in, and then run the code again. And that runs fine. Is that okay? Does that answer your question about the numbers on the side? The numbers are basically how, in what order you run the cells. So I could now run just this one, for example. So if I run here, this turns to 5 because I've run it after the rest of them. So does anyone have any more questions about this? Great. Okay. Oh,
Yeah. Okay. Good. Just continue. Yeah.
Continue. Okay. Great. So this is a very simple example of Jupyter notebooks, and how you can kind of simply start with Python kind of in here. I'll now quickly show you what we'll go through tomorrow and the kind of data that you'll get. But I won't go through it in detail. I can go through that in the session tomorrow, and then hopefully you've got a bit of time to then digest all of the information. So if I go back here, so then this is kind of the file that I showed you, and then so this is the knowledge exchange notebook that we'll be using. So then this is the notebook that you'll receive tomorrow. And you can then see kind of the different stages that we were just talking about. So here, like, you import all of the modules. So like I said, in this one, we just had a couple. But now in this new one, there's a lot more going on because we need a lot more tools to be able to run this module. You can see here that Parcels is being imported. And you've got the field set and the particle set all already, and other things to do with Parcels as well. Like I said, I'm going to go through this really quickly. I don't expect you to fully understand this. We can run it all tomorrow, and run each bit, and I can problem solve with you tomorrow as you're running it. So then we've got a field set, which is loading in some data, some NC files. And then you're setting up this field set, and then you're setting up the particle set with all different. You've got your number of particles here. You've got your lon and your lat, kind of your longitude and latitudinal values. So the location of where you want, where you would like to release your plastic particles. And then here is where you actually run the model and kind of output to file. And then you've got different plotting options at the bottom. So there are lots of different parts of this piece of code, and you'll learn more about that tomorrow. But other than that, I think that's probably okay for today. I don't want to overload you with information, but does anyone have any questions first off, either about what I've gone through today or tomorrow? I'll stop sharing for a second so I can see everyone. Oh, here we go. Can you include? Yeah, so cool. You've used OceanParcels before. This is really good. So this is and can we include the ocean density variable in the particle set? Yes, you can. Probably won't go through that tomorrow, kind of in the wider group, but I can definitely talk to you about it kind of individually. You can put, I think there's an assumption in OceanParcels of the water density itself. I think you can override it, you can change it, but you can also change the particle density. So you can change how so we can change kind of how dense the particle is and how that sinks through the ocean. You'll need to make sure that you've got a kind of a three-dimensional ocean model for that, because obviously as it sinks, it's going to go through different layers. So the model that we'll be giving you tomorrow is just the surface layer, but HiCom itself is 3D. So if you want to go and download kind of the whole all the layers, you can do that. But for tomorrow, for kind of the wider group, we'll keep it simple, just to one layer. I'll have a look today about kind of the density and how to include that for you, and hopefully we can go over it tomorrow. How can we get the syntax of the plastic ocean? Oh, so kind of just the title and stuff. Hang on, I'll share that again. This syntax, is this what you mean here? Yes, okay, great. Sorry, not very used to Zoom. Share, there we go. So yeah, so here I can insert different cells. So like I said, you can have lots of different types of cell. Insert cell above. I can say this is a heading. You can say this is a heading, so you do use that with a hash kind of in, so you want the markdown in this drop down list here. So this is a heading. You can also say this is a smaller heading, so 2 hash symbols makes a slightly smaller heading, and then this is some information before you start. So this can be like your paragraph text. And then if you run that then turns into kind of your title. So you can create quite a nice layout of your code, which makes it very easy to follow. You can also kind of upload pictures in there if you want. Search, I'm sure you can. I've never done that before, but you can put different pictures and different, you can put links in here to different websites if that's helpful. For example, here is more information on, like that. And so it's a really nice way of just kind of having all your information in your code all together and kind of seeing it all visually. So I hope does that answer your question? Great. So does anyone have any other questions? Sorry, I know I finished a little bit early, but it's quite a lot of information to digest, so it's probably good that you have a bit of a longer break, right?
Is there any question for online participant?
Daniel. Daniel. Can you hear me?
Yeah, I can hear you.
Oh yeah. So how we validate this model? I mean, when we do numerical analysis in OceanParcels, do we need to make something or just numerical analysis to validate this model?
Is that how are you going to get the model? How are you going to get OceanParcels?
Oh, how we validate the result of the model?
The results?
Yes.
Right. Yeah. So the results are in a NC file. So in this kind of netcdf file, and you can then load that in and start to kind of analyze it there. So if I just jump back to this. So in this code, for example, that you'll be using tomorrow, again, I'll go through it in much more detail tomorrow, but you're saving a file out called file name. And you could change that name if you want. It's just kind of a placeholder for now. Like I said, that puts all the information, so the longitude, the latitude, and the time of all the different particles. And then you can load that back in and kind of start to analyze it. So here you've got kind of the time value. You've kind of loaded this in as data, and you can lay out the time value. And yeah, so kind of all and the kind of lon here and the lat. But tomorrow I can kind of print out for you on the screen kind of what the data will look like, and kind of easy ways to access it. Like I said, the data structure is a little bit complicated. You kind of need to do a little bit of analysis with the time series before it kind of starts to look a little bit usable. But yeah, that's kind of generally how you access the results file. Is it saves it to something called an NC file, and you don't have to use Jupyter notebooks or Python to analyze that. Any type of code that can open an NC file. So I use MATLAB a lot. You could use MATLAB, you could use R, so kind of different types of code you could use to then analyze this data. But tomorrow we'll use it all on Python, just to make it simpler. Is that okay? Did that answer your question?
Yeah, okay, thank you.
Great.
From other participant? Yes, from Ucia.
So it's what kind of data did you use for the data sets? So the data for the project that we'll be doing tomorrow is a HiCom ocean model. So the data, so again, if I share my screen, sorry, I keep sharing, not sharing my screen, but so you'll get a file like this called HiCom, and I've split it into, so then you get you're going to get 12, 1, 2, you get about 10 months worth of data, split into kind of the dry season and the wet season around Sulawesi Island. And you can then kind of concentrate just on that region. But all of the data is broken up into the different months. So here you've got April, May, June, July, August, September, October, and they're all in their own NC file. But don't worry about opening and closing all of these. That it should be in this code. You can kind of, where this has gone from me, there we go. You can kind of upload and kind of use all the data at once, kind of through using this method that we'll go through tomorrow. But yeah, the kind of data that we use to set up the model is the HICOM ocean model in kind of NC data format, NC file format. And then we don't use any data for the kind of locations of the particles. You can just, sorry, let me go down. You can put any location you want that's within the domain, kind of within your lon and lat variable. Okay, so there's a couple more questions here. What is the limitations of OceanParcels? What should be considered? Really good question. So there's a few limitations and errors kind of within the model, as with all models are. There's kind of more information there's lots of papers by Eric van Sibbel, who made the model itself, and all of he's on Twitter, and all of his papers will go through the actual model in a lot of detail and kind of all of the limitations. But it really does depend on kind of how you're using it, but kind of the sinking velocities and the densities and the amount of particles will depend. Also, a limitation could be your computer. Like I said, the amount of particles being released into the kind of into the environment every hour is sometimes in the order of millions, hundreds of millions even. And so, you know, my computer, especially, unless you're using kind of a big supercomputer, really can't deal with that. So often you have to scale back the amount of particles you're using to be able to run it in a sensible time. So that could be a big limitation. You're not kind of dealing with the same kind of order of magnitude, but you kind of want to get to as many particles as your computer allows in a sensible amount of time. And then how to validate the model, how can we make sure the result of the model is kind of accurate, I think. So yeah, another great question. Well done, great modeling question. So the HICOM model is, the ocean model that we'll be using is open access and already validated. And I think it's pretty good for the kind of Indonesian region. So we can be quite confident that the ocean current data that we're using is realistic. But then in terms of the output of the particle tracking, that's when it gets a bit more tricky. There's a few ways to validate a particle tracking model. We won't go into that in kind of this session, but what you can do is you can get kind of drifters kind of in the ocean. So some of that data is available publicly. I know of a few ones that are going around the UK at the moment. They might have some in Indonesia and kind of around Sulawesi Island. But you can then try and match the drifter track to your kind of particle track in your model and kind of see where that differs and see how different they are. It becomes quite tricky, kind of, it's almost related to your first question, because quite often kind of wind speeds aren't included in ocean models. And of course, if something like a drifter is floating on top of the ocean, that's going to be influenced quite heavily by wind speeds. So validating particle tracking models is quite tricky, and you can do it, but I think the most important thing to know is that the ocean model and the ocean currents are the ones is correct and kind of realistic to real ocean conditions.
There any question here from offline participant or online participant? Because Nia still have a plenty of time to ask until 2:24. I mean 10 minutes. Okay, from Pusidrosa Chandrasa.
Great, another question. So which model is compatible with Parcels? So there's lots of different ones, and there doesn't necessarily have to be a compatible model. If it's not compatible, you just have to do a bit of kind of pre-processing of the data to be able for it to be read by OceanParcels. But one of the easiest ones to read in is Nemo model. I've worked with Nemo before, and I've worked with the HiCom data before. I also think there's a couple of others, but I can't think of them off the top of my head, but those two definitely work well. And yeah, I think they're trying to add new ones all the time. Again, if you go online, there's kind of quite a active GitHub community there where they're trying to develop the model, and you can see what they're working on. Actually, I'll show you the OceanParcels website, which might help. So if So this is the OceanParcels website. This is oceanparcels.org. So you might have seen this while downloading it or kind of Googling it in the past. This should give you a lot of information for the questions about kind of limitations and kind of the more technical modeling questions. This is kind of the main piece of literature on the model, and it kind of goes into quite a lot of technical detail about the kind of the ins and outs of the model. And then you've got kind of installation instructions, which you've received, I think. But then also you kind of got different tutorials here. So this is also all set up in Jupyter notebooks. So you can have a look at kind of different parts of the model and what you'd like to do. So here you've got kind of Nemo 3D. So this is setting up the model for kind of the input of the Nemo Ocean model. What else? You've got plotting tutorials down here somewhere. Yeah, so you've got plotting tutorials, particle interaction, which is the kind of the tuna video that I showed you of kind of all the different things. So for example, if we go into the Nemo 3D tutorial, for example, great, that's file not found. Here you go. So this is kind of an explanation of how to read in the model into OceanParcels, and gives you some outputs and suggestions and examples of how to do it. So this is a really useful website to have kind of just in your mind. In terms of development status, like I said, it's got a very active GitHub community. So here you can see the different things that they're hoping to do and kind of experimenting with. And these are things that are coming up in the future. So it's a model that's always being expanded, that's for sure. And then another part of the website is, so if you go on to the documentation. So this is kind of the manual of OceanParcels. And like I showed you on Google before, it kind of shows you kind of how to set up quite a lot of the functions in Parcels. So here, this is kind of how you're setting up the particle set and the particle file. And here you can have like all of these, you can read about what all these different variables mean. This is a lot of information, and you do not need to read this like cover to cover, like the whole page. But if, for example, you're having an error with the field set module, you can click on that, and that might help you solve a couple of problems. So if I go back to this, you've also got frequently asked questions. So this information, this website has a lot of information about the model in general, which may be helpful.
Is there any question? From offline participant, do you have any question? Okay, still from offline participant here, and I think from online also clear for your course. Wait a minute. Okay, I think it's done for section. Thank you, Nia. I know in UK time it's still early morning, but thank you so much for your time. Stay healthy and see you tomorrow.
Great, thank you so much, everyone, and thank you for the great questions. Yeah, see you tomorrow. Looking forward to it.
Yeah, thank you, Mia. So tomorrow we will start at 1 p.m. And also Nia will lead for
Nia, sorry.
Yes?
Already. Can I ask again? Sorry. Hello, Nia.
Hello, yeah, I'm here.
Okay. I will show my screen again. I just curious why my program is error because I already compared. This is yours. This is me, and I step by step I already follow you. But after I run, the result is like it's error. Error. What's the problem? Maybe just that simple. Can you see my
Yes,
screen?
yeah. So you need to run the first two. You haven't run the first two boxes.
Okay, I will.
Hello? Is it clear for Mr. Eric? Or still
Okay.
connection?
I will try by myself. Okay. I will try. Okay.
I can help some more if you want. I'm still here.
Again.
Thank you, Nia.
Is it all working? Is it okay?
I get the answer for other participant. Oke, terima kasih Pak KB. Thank you Pak KB. Oke. Okay, I got the result. Thank you, Nia and Pak KB. Okay.
Nia, do you still?
Hello. Sorry.
Do you have you finished the lesson? I mean, do you still anything to explain for today, or just?
No, I'm all done now, and yeah, I'll leave and I'll be back tomorrow.
Oh, okay. Okay.
Thank you. Bye.
Others? Okay, bye-bye. Ya, baik. Ibu Nia sudah meninggalkan kita. Alangkah lebih baiknya menggunakan bahasa Indonesia. Oh ya, untuk teman-teman partisipan offline dan online, dari panitia sudah memberikan, sudah merekam sesi kursus yang tadi. Jadi kalau misalnya ada yang mau minta rekamannya, bisa diberikan dan minta langsung ke panitia. Selanjutnya, oh iya, untuk teman-teman offline partisipan, kita menyediakan vitamin dan vitamin. Jadi buat teman-teman partisipan yang offline sebelum pulang bisa mengambil ya kalau mau. Selanjutnya, sebelum kita melanjutkan ke pembicara kedua, ada dari panitia yang akan
terima kasih kepada para peserta baik yang online maupun yang offline. Karena tadi sudah dalam bahasa Indonesia, I will talk in Indonesian too. Gitu. So basically bahwa dalam 3 hari ini kita akan berbicara tentang OceanParcels yang dibawakan oleh Nia Jones dari Bangor University, dan kebetulan karena di sana masih pagi, jadi kemungkinan dia akan bekerja mulai jam 9 pagi di sana. Jadi mungkin karena hari ini adalah introduction, jadi mungkin besok kita akan lebih banyak untuk melakukan codingnya. Jadi mudah-mudahan kita bisa mempunyai software dan aplikasinya hari ini gitu. Nah, kemudian mungkin sampai jam 3 mungkin kita bisa hands-on ya di laptop sendiri masing-masing, mencoba sendiri. Setelah itu karena ada para peserta yang offline, kami juga menyediakan break dan mungkin juga dengan sholatnya. Jadi mungkin kita akan ketemu lagi mungkin di jam 3:30. Nah, pertemuan nanti di jam 3:30 mungkin kami akan memberikan video tentang merit degrees, dan kemudian kita coba dengan apakah semua peserta di sini baik yang online maupun yang offline sudah pernah mendownload data dari HiCom dan yang lainnya dan portal lainnya. Karena mungkin karena backgroundnya di sini kami lihat bahwa ada beberapa dari merit science mungkin sudah terbiasa dengan HiCom. Beberapa yang belum mungkin bisa nanti kami ajarin atau kami sharingkan bagaimana cara mendownload HiCom, karena kami tidak melihat bahwa Nia akan memberikan materi tentang itu sendiri. Nah, selain HiCom, portal datanya kita juga nanti dapatkan dari IRC dan sebagainya. Nah, kemudian the last thing is bahwa kalau besok mungkin di akhir itu di pertemuan besok di jam yang sama 3.30 sore juga. Kalau memang masih ada waktu, kami akan coba memberikan materi tentang satu lagi software open source yang dikeluarkan oleh Noir, yang hampir sama dengan OceanParcels, tapi dia black box. Artinya sintaknya tidak keluar di situ, tidak kita buatkan sendiri, tapi tidak ada. Yang dinamakan dengan Deno, DNO. Nah, ini sudah dipakai ketika tsunami di Jepang waktu itu, dan mudah-mudahan besok bisa memperkaya beberapa software tentang berendubis. Mungkin dari kami panitia mungkin seperti itu. Kemudian nanti di akhir acara di hari ketiga pada penutupan nanti mungkin kami akan memberikan sedikit ini ya, sedikit ada best partisipan juga dan best presenter gitu untuk nominasinya untuk kita semua. Jadi mudah-mudahan ada peserta yang bisa aktif untuk bertanya ataupun berdiskusi. Dan besok sore juga kita akan ada penugasan seperti independent project gitu. Jadi kita akan apa yang kita lakukan mungkin berdua atau bertiga dengan peserta-peserta yang sudah kami lakukan. Mungkin demikian untuk sesi ini. Jadi kita akan bertemu kembali di pukul 3.30. Nah, sampai pukul 3 mungkin bagi ada yang mau bertanya mungkin di grup, di chat ini Zoom-nya akan kami simpan terus. Jika ada yang mau bertanya mungkin bisa ditanyakan lewat chat atau mungkin bisa raise hand karena kami di sini masih aktif. Terima kasih, thank you. Mungkin kami sapa dulu beberapa teman di sini. Selamat datang Pak Erik ya, Pak Erik yang saya kenal. Kemudian
Makasih Pak, sama-sama.
Bu Farah yang dari US ya, terima kasih Pak. Sampai ketemu nanti jam 3.30 ketika ada pertanyaan bisa di sini.
Selamat sore maksud saya kepada teman-teman partisipan online diharapkan segera kembali ke depan laptop. Dan untuk teman-teman offline partisipan silakan ke ruangan meeting UTC kembali. Terima kasih. Sebelum kita melanjutkan, kepada teman-teman online, apakah sudah ya, kepada seluruh peserta diharapkan untuk segera bersiap kembali karena acara akan segera dimulai. Sambil menunggu teman-teman di ruangan untuk partisipan offline untuk kegiatan selanjutnya. Bentar ya. Oke, Pak Mario, terima kasih sudah bergabung dan beri kabar. Oke, siap nggak apa untuk Pak Mario kalau mau mematikan video kamera video. Jadi untuk pemateri selanjutnya yaitu ada Bapak Kemaal yang akan menjelaskan tentang beberapa data oceanography. Tapi sebelum itu akan ada pemutaran video tentang sampah laut. Oke, terima kasih Pak Danang udah konfirmasi di chat room. Kata Pak Danang dari BMKG udah siap, untuk juga teman Bapak dari Chandrasa dari Pusit Dosal juga. Oh ya Pak, nggak apa-apa deh kalau misalnya mau menghemat kuota dan mematikan kamera, tapi tetap stay tune terus ya Pak di depan laptop. Karena seperti yang tadi disebutkan oleh Pak Noir, di akhir acara nanti di hari ketiga akan ada pengumuman best partisipan yang pastinya yang akan mendapatkan hadiah menarik prize money. Oke, diulang Mas Dursa, sambil menunggu teman-teman offline juga bersiap kembali. Jadi diingatkan untuk seluruh peserta, baik peserta online dan offline, untuk ikut turut aktif dalam kegiatan workshop ini. Karena di akhir acara nanti di hari ketiga akan ada pengumuman best presenter dan best partisipan yang masing-masing dari pemenang ini akan mendapatkan hadiah yang menarik. Ini enggak. Terlalu jauh ke bawah.
Ya.
Selanjutnya mungkin nanti di grup akan dijelaskan lebih lanjut di grup WhatsApp tentang syarat best presenter dan best partisipan, bagaimana cara mendapatkannya. Mungkin sekarang bisa langsung diputar ya untuk panitia video tentang sampah laut.
Enggak.
Boleh banget. Karena kita juga udah ini kan, udah waktunya jam-jam ngantuk di jam sore. Mungkin buat teman-teman yang offline, yang partisipan yang hadir di UTC Unpad bisa sambil mengambil beverage di belakang. Dan nanti di akhir acara akan ada teman kita dari panitia, Ibu Adel akan memimpin kegiatan. Nah, oke, udah bisa dimulai mungkin beberapa video yang akan kami putar sebelum dilanjutkan ke pembicara kedua. Terima kasih.
Dalam indeks kesehatan laut, kita sangat rendah sekali, yaitu peringkat di 145 dari 221 negara. dan salah satunya adalah akibat daripada banyaknya sampah yang masuk ke lautan. Indonesia dalam posisinya di negara yang dibatasi oleh Samudra Hindia maupun Samudra Pasifik itu memegang peranan yang sangat penting sebagai trapping sampah atau penjebak sampah, dan juga dia sebagai pengalir sampah ke Samudra Hindia. Sampah yang masuk ke lautan ini sangat berdampak kepada ekonomi, kepada ekologi juga. Hal yang signifikan sampah di lautan berasal dari aktivitas manusia.
Sampah yang terbawa oleh arus itu bukanlah sekedar fiksi. Pada tahun 92 ketika kapal Hongkong yang membawa mainan anak-anak terdampar di lautan Pasifik, dan hingga pada tahun 2007 sampah-sampah mainan anak itu masih mengelilingi dunia, berputar mengelilingi samudra. Hasil penelitian kami menunjukkan di 60 lokasi di Indonesia, terutama di wilayah Jawa dan Bali, kami menemukan bahwa hampir sekitar 90% data kami adalah plastik, diikuti dengan foam, kemudian beberapa sampah jaring-jaring ikan.
Untuk sebaran sampah makro di sekitar pulau dan juga pesisir Kupang, di mana terdapat 6 pantai yang menjadi lokasi penelitian, di mana lokasi tersebut merupakan pantai wisata. Sampah laut yang ditemukan terakumulasi di area pasang tertinggi serta di area lalu lalang aktivitas penduduk. Jenis sampah yang didominasi oleh pembungkus plastik, kemudian styrofoam serta jaring.
Sebagai negara kepulauan, trapping sampah kita masuknya dari Laut Cina Selatan, Selat Makassar, dan kemudian Halmahera dan Laut Maluku. Dan kemudian juga kita mengalirkannya melalui Arlindo atau arus lintas Indonesia ke Samudra Hindia.
Aktivitas manusia telah memberikan dampak yang signifikan bagi kehidupan di laut. Salah satu contohnya yaitu masalah sampah laut. Fakta di lapangan menunjukkan bahwa sistem pengolahan sampah di Indonesia belum mampu menangani banyaknya jumlah sampah yang ditemukan dari aktivitas manusia. Akibatnya, banyaknya sampah terbawa ke sungai dan akhirnya berakhir di laut. Hal yang dapat kita lakukan seperti membawa tumbler dan juga tas belanja yang dapat dipakai ulang. Kurangi penggunaan produk sekali pakai dan jangan buang sampah sembarangan. Mari kita peduli dengan lingkungan sekitar, dukung terus program pemerintah, dan tunjukkan apresiasimu sebagai generasi masa depan.
metric tons of plastic trash enters the sea from land every year. The equivalent of 5 plastic bags filled with trash for every foot of coastline in the world. Across our ocean, plastic trash flows into circulation, dispersed almost everywhere, but concentrating in huge swaths in the midst of global currents, breaking down into smaller and smaller pieces, ingested by species across the marine world, and sinking to the bottom of the sea.
Anyone can make plastic anywhere in the world and sell it anywhere else in the world. There's no design paradigm, there's no barriers. In order to solve the plastic packaging problem, we need to effectively rethink the entire system. From one which is linear, i.e. take, make, dispose, to one where it can be recovered and fed back into the economy as a valuable plastic material, or one where it is biobenign and it can enter the environment. The ultimate goal of the new plastics economy is to design an economy where plastic packaging never becomes waste. And to do that, we need every single player in the chain to change the way that they do things.
But marine pollution comes in many forms. Industrial, agricultural, and urban waste also sweep into the sea, fueling explosions of algae that rob marine ecosystems of the oxygen they need to survive. With sustained pollution, these areas become dead zones, which already exist in more than 400 locations across the globe. But nutrient pollution can be managed through change in major contributing systems like agriculture.
If you eat, you're involved in agriculture. So it's a problem that all of us have to work together to solve. Soil health is critical for water quality. It's the first thing we have to focus on. Here on the farm, organic matter is the key thing that we try to improve. The more organic matter you have in the soil, the better the soil can hold on to nutrients like phosphorus and nitrogen. Organic matter keeps it from leaching out of the soil. It grabs onto it. That's good for the farmer. It's also good for water quality in the bay. For any farmer to change their system is tricky, and it takes a lot of work. I think all farmers want to. It's learning different processes, practices that allow you to do it effectively. That becomes a key.
Akan dilanjutkan dengan pembicara Bapak Kemaal dari Ilmu Kelautan Universitas Pajajaran. Beliau akan memaparkan materi mengenai Oceanographic Data Downloader website. Jadi waktu dan tempat dipersilakan untuk Pak Kemaal, silakan.
Baik semuanya, Assalamualaikum warahmatullahi wabarakatuh. Selamat sore semuanya. Terima kasih juga kepada para hadirin yang terhormat yang telah masih mengikuti rangkaian kegiatan pada hari ini. Mungkin perkenalan sedikit, nama saya Kemaal Sayyid dari Ilmu Kelautan 2018. Di sini mungkin saya akan menjelaskan beberapa contoh website penyedia data oceanography yang biasa digunakan untuk mengambil data sekunder untuk pengolahan data pendidikan dan riset yang lebih luasnya. Pertama mungkin dari definisi website penyedia data oceanography itu sendiri, jadi merupakan suatu kumpulan data secara real time maupun di real time dari beberapa parameter oceanography yang untuk mendapatkan datanya sendiri atau yang dikumpulkan itu melibatkan beberapa pakar yang telah
kredibel dalam melakukan validasi. Kemudian beralih ke data urgensinya juga dengan latar belakang kondisi laut Indonesia yang sangat atau dunia yang sangat dinamis dan kompleks. Terus di setiap wilayahnya itu terdapat beberapa perbedaan juga. Maka untuk melakukan inventarisasi data itu diperlukan website yang data Oceanographic yang tujuannya diantaranya untuk monitoring perubahan yang terjadi ataupun pemanfaatan secara luas terhadap disiplin ilmu yang berkaitan. Kemudian dari berdasarkan hal tersebut terdapat 3 poin utama yang akan dibahas mengenai kegunaan website data Oceanographic. Yang pertama diantaranya adalah tentang kebutuhan inventaris data sekunder. Kemudian si data Oceanographic itu sendiri digunakan untuk riset dan penetapan kebijakan pada suatu wilayah tertentu, dan juga untuk komparasi data atau pembanding data dan validasi terhadap beberapa website yang di data Oceanographic. Baik, mungkin dari contoh yang pertama terdapat data website dari HMWF atau European Center of Medium Range Weather Forecast. Ini tuh merupakan website yang berdasarkan dari organisasi antar pemerintah yang independen yang didukung oleh 34 negara. Juga HMWF ini terdapat data-data penelitian yang beroperasi selama 24 jam selama 7 hari. Kemudian HMWF ini membuat perakiraan dalam hal jangka bulanan, musiman, bahkan hingga 1 tahun ke depan. Untuk data parameter yang tersedia sendiri dari HMWF diantaranya ada data cuaca, terus ada analisis iklim dan data spesifik lainnya. Untuk contoh dari HMWF ini sendiri, pengunduhan datanya kita menuju alamat website yang terlihat pada screen. Kemudian biasanya kita di sini melakukan registrasi atau login dulu terhadap HMWF-nya dengan membuat akun. Kemudian apabila sudah, kita tinggal memilih beberapa contoh data yang tersedia oleh HMWF, diantaranya seperti toolbar analisis yang di dalamnya terdapat beberapa tipe data berdasarkan klasifikasi dari satelit juga. Misalkan saya contohnya yang ini. Oke, dan seperti yang tadi saya sebutkan sebelumnya, usahakan untuk membuat akun terlebih dahulu untuk kita dapat mengunduh data dari HMWF. Nah, dari data yang ditampilkan, ini ada beberapa data seperti level termasuk di kedalaman, kemudian ada potensial, kemudian ada beberapa data lainnya seperti yang sifatnya daily maupun rata-rata bulanan maupun rata-rata dari bulan itu sendiri. Nah, kemudian di pilihan yang awalnya, yang di atasnya itu ada beberapa data time series dari masing-masing tahun yang tersedianya dan bulannya. Kemudian ada data pengulangan data setiap berapa jam sekali. Lalu di bawahnya ada beberapa parameter yang bisa diunduh, di antaranya seperti UWIN dan PWIN untuk resolusi yang 10 meter maupun 100 meter, dan juga beberapa data suhu seperti yang terlihat pada gambar. Jadi setelah kita memiliki kebutuhan data yang memang dibutuhkan untuk penelitian ataupun untuk kegiatan lainnya, untuk aktivitas lainnya, nanti akan dilanjutkan ke window selanjutnya yang mengarah ke proses pengunduhan apabila sudah melakukan registrasi. Baik, lalu selanjutnya terdapat dari Copernicus. Untuk Copernicus ini sendiri merupakan website penyedia data yang sifatnya gratis juga dan bebas untuk digunakan, dan juga terdapat fitur-fitur seperti support dan expertise atau pelatihan dan lokal karya yang dapat dilakukan secara offline maupun online, dan juga terdapat materi literasi mengenai kelautan yang sama-sama terbuka dan gratis. Selain itu, data kelautan yang tersedia juga secara global maupun regional terhadap wilayah data tertentu, seperti contohnya Laut Mediterania, Laut Hitam, Laut Baltik, dan sebagainya. Sedangkan untuk parameter yang disediakan oleh Copernicus ini sendiri, diantaranya terdapat data suhu, salinitas, elevasi muka laut, kemudian kecepatan arus, angin, terus data-data kimia lainnya seperti nutrien, produktivitas primer, keperluan, dan sebagainya. Untuk contoh mengaksesnya, kita menuju alamat websitenya di resource Copernicus, resource.marine.copernicus, yang kurang lebih nanti datanya seperti ini. Kemudian untuk melakukan pengunduhan data, biasanya kita melakukan akses data, dan terdapat beberapa pilihan, seperti dari monitoring indicators, maupun state report, dan sebagainya. Nah, seperti yang tadi saya sampaikan sebelumnya, terdapat data yang berhubungan dengan kebijakan, expertise, data itu sendiri untuk kegiatan eksplorasi dan sebagainya. Nah, mungkin sambil menunggu, seperti yang disampaikan, untuk Copernicus itu sendiri terdapat data-data seperti data primer, data sekunder mengenai antara lain suhu, salinitas, tinggi muka laut, kecepatan arus, angin, nutrien, produktivitas primer, dan juga beberapa data yang berkaitan dengan lingkungan. Nah, ketika kita mengakses data dan kebutuhan data tentang apa, kita bisa memilih regional domain atau area yang ingin kita ambil datanya, kemudian data time seriesnya dari kapan sampai kapan, dan beberapa parameter yang disediakan oleh website dari Marine Copernicus itu sendiri. Mungkin seperti itu untuk yang Marine Copernicus. Nanti seperti yang sebelumnya, apabila kelengkapan datanya sudah dipilih, nanti mungkin akan dapat diakses juga data yang telah terunduhnya. Baik, selanjutnya ke website APDRC atau Asia Pacific Data Research Center. Untuk website ini sendiri merupakan website yang lebih spesifik mengenai wilayah Asia Pasifik. Di antaranya fitur dataset yang disediakan terdapat parameter kimia fisika dari lingkungan atau wilayah yang berada di kawasan Asia Pasifik yang berkaitan dengan laut, atmosferik, kemudian interaksi antara laut dan atmosfer, dan data-data tersebut berdasarkan data citra satelit. Untuk websitenya seperti ini kurang lebih tampilannya. Untuk cara pengunduhannya di sini terdapat beberapa penyedia data berdasarkan satelit-satelit yang citra satelit yang mengambil data tersebut. Untuk kebutuhan datanya sendiri, di sini terdapat beberapa pilihan sesuai dengan kebutuhannya. Kemudian biasanya sih yang digunakan itu yang live access server. Nanti tinggal bisa dicari juga. Tapi apabila kita memang membutuhkan data awalnya yang secara lebih luas, itu bisa dipilih juga di pilihan menu di bawahnya, seperti data in situ, atau data pengambilan primer, data dari satelit remote sensing observation, dan analisis produk. Nah, ini juga terdapat beberapa jenis datanya juga untuk grading type-nya, diantaranya terdapat secara Lagrangian maupun berdasarkan station data. Lalu di waktu coverage-nya atau all-time coverage-nya terdapat beberapa pilihan diantaranya seperti ini real time, forecast, fixed time, statistik, klimatologi, paleo, dan non-time. Nah, ini untuk yang pilihan terakhirnya, berdasarkan pilihan data secara time series-nya, apakah secara harian, untuk bulanan, maupun mingguan, dan lain sebagainya. Nah, mungkin sedikit yang harus diperhatikan apabila di beberapa website ini, tidak semua yang kita pilih itu terdapat dapat basic datanya gitu. Mungkin saja beberapa datanya belum diupload, ataupun terkait dengan inventaris data yang tidak terlalu lengkap. Seperti ini, misalkan memang kebutuhannya, terkadang memang kebutuhan antara untuk penelitian maupun penyediaan data dari beberapa website itu tidak berbanding lurus. Kadang memang tidak ada data yang ditampilkan maupun datanya terlalu melimpah. Nah, seperti contohnya untuk SST atau surface temperature, sea level, dan ocean current atau arus, data yang tersedianya hanya dari HICOM untuk analisis global secara Hawaiian dan island religion. Nah, kita ingin mengambil data dari AirDrop, itu nanti akan ditampilkan seperti terlampir pada screen, dan mungkin nanti kita akan memilih secara kebutuhan datanya itu sendiri, seperti apakah datanya time series ataupun sesuai dengan wilayah penelitiannya. Dan juga untuk penggunaan data itu terdapat beberapa parameter seperti resolusi spasial dan temporal yang dibutuhkan agar data tersebut dapat digunakan. Nah, ini contohnya dari yang tadi, kita tinggal memasukkan data time seriesnya kira-kira mulainya kapan dan berhentinya kapan, tapi tergantung pada ketersediaan datanya itu sendiri juga. Lalu untuk secara spasialnya menuliskan koordinat secara desimal. Lalu setelah itu kita tinggal submit, maupun untuk grid variabelnya dapat diatur sesuai dengan kebutuhan data. Ya, sambil menunggu untuk proses pengunduhan. Ya, untuk tipe datanya sendiri biasanya beragam, tapi untuk yang biasanya digunakan untuk modeling maupun modeling distribusi seperti yang dicontohkan oleh Miss Mia tadi, oleh software OceanParcels, biasanya data yang dibutuhkan berupa NC atau NCDF. Ya, baik. Mungkin sambil menunggu juga karena di sini terdapat pernyataan untuk menunggu ya. Mungkin apakah ya kembali lagi ke partisipan apakah akan menunggu sampai proses downloadnya berhasil atau kita bisa ke website lain sambil menunggu yang lain, menunggu download yang lain juga. Baik, sepertinya kita akan lanjut dulu aja. Kemudian website yang keempat, yaitu website yang baru dibentuk juga di tahun ini berdasarkan kerjasama dari Unpad dan universitas di Filipina, yaitu menghasilkan website penyedia data yang bernama PUSDI atau Oceanographic Data Center. Jadi website PUSDI ini merupakan website yang secara online terdapat sumber daya kelautan dan iklim. Nah, datasetnya juga cukup beragam, mencakup beberapa parameter yang dikumpulkan berdasarkan beberapa pengukuran yang diantaranya salah satu pengukurannya berdasarkan dari instrumen yang berhasil dibuat juga, yaitu yang bernama area. Sedikit menjelaskan, mungkin area ini seperti jenis drifter yang dapat mengukur beberapa parameter fisika dan kimia dari laut, baik itu di permukaan maupun berdasarkan stratifikasi volume air. Lalu data yang dapat diunduh diantaranya data yang berkaitan dengan data atmosfer, fisika, kimia, biologi, maupun data-data biologis seperti data biota dan ikan dan ekosistem yang sudah terkumpul sebelumnya. Untuk dari website PUSDI itu sendiri dapat diakses pada link berikut. dic.pudc.org. Nah, untuk tampilan website seperti ini, data-data yang dikumpulkan dari website PUSDI ini, diantaranya berdasarkan riset tahunan maupun data primer ketika dilakukan kegiatan survei yang dilakukan oleh mahasiswa ilmu kelautan maupun beberapa kemitraan yang menjadi distributor ataupun kontributor yang bekerja untuk pengembangan website ini secara datanya. Untuk pengunduhan data itu sendiri bisa diakses melalui seperti ini, menu features, kemudian ke dataset, dan nanti akan ditampilkan data kartografi mengenai ketersediaan data dari masing-masing wilayah yang pernah dilakukan penelitiannya. Nah, untuk data source itu sendiri, sejauh ini karena masih ada pengembangan juga, terdapat 3 pilihan, yaitu berdasarkan ekspedisi, berdasarkan kegiatan field trip, maupun berdasarkan data-data yang diperoleh dari tesis. Lalu untuk parameternya itu sendiri terdapat lumayan banyak. Jadi kalau misalkan kita ingin mendapatkan data nasional atmosferik, itu ditandai dengan palet berwarna hijau maupun simbologi yang berwarna hijau disesuai wilayah penelitian yang ada di sejauh ini seluruh Indonesia. Lalu apabila kita ingin menambahkan author atau bekerjasama dengan author, nanti mungkin akan bisa disampaikan di sini. Dan apabila kebutuhan data kita mencakup data time series, kita tinggal memilih data yang dibutuhkan berdasarkan hari, minggu, bulanan, ataupun tahunan, ataupun secara musim. Seperti itu. Dan apabila ingin lokasinya lebih spesifik juga, kita tinggal menuliskan koordinat yang terkait selama ketersediaan data di wilayah tersebut masih ada. Lalu untuk pengunduhannya sendiri, saya contohkan apabila kita ingin mengambil data di sekitaran Teluk Jakarta, Kita ke pilihan yang ini, lalu menarik lokasinya. Dan lakukan pengunduhan data. Nantinya data yang ditampilkan akan berupa bentuk Excel yang dapat diolah atau diolah kembali menjadi NC melalui beberapa software seperti contohnya software ODV. Kemudian mungkin yang terakhir yang bisa saya sampaikan mengenai software goods atau genome online oceanographic data server. Khusus untuk software ini berkaitan dengan penggunaan software yang bernama genome. Jadi genome ini merupakan software pengembangan dari NOAA yang tujuannya adalah untuk melakukan visualisasi atau distribusi mengenai beberapa partikel-partikel yang tersebar di permukaan laut. Partikel tersebut bisa merupakan marine debris contohnya, kemudian bisa juga spill tergantung dengan pengaturan dari berat partikel maupun ukuran dan faktor-faktor pendukung lainnya seperti pola sebaran angin maupun arus. Nah, kemudian untuk website goods ini sendiri merupakan website yang dikembangkan untuk membantu penggunaan genom yang pada outputnya menghasilkan suatu pemodelan dari sumber data yang kompatibel dengan genom itu sendiri. Untuk ketersediaan datanya sendiri, di software goods ini sendiri terdapat data angin, kemudian database maps-nya atau wilayah penelitian yang digunakan. Ini merupakan data kartografi dan beberapa pendukung lainnya seperti untuk data arus yang diasosiasikan dengan ICOM. Kemudian untuk software genome itu sendiri dapat dilihat di screen juga, merupakan akronim dari General NOAA Operational Modeling Environment atau software pemodelan yang digunakan untuk memprediksi kemungkinan distribusi ataupun lintasan yang mungkin mempengaruhi atau dipengaruhi oleh faktor-faktor tertentu pada badan air. Nah, secara keseluruhan genome ini merupakan software yang mendukung skenario distribusi yang disesuaikan dengan cepat dan insidental atau disturb incident. Pemodelannya OR dan R dan dengan menggunakan metode diagnostik. Jadi contohnya seperti yang terlihat pada gambar yang ini merupakan salah satu visualisasi akhir dari software genome itu sendiri, di mana saya juga mencoba untuk memetakan pola distribusi dari marine debris berdasarkan pergerakan dari sampahnya maupun sampah-sampah laut yang sudah sudah menetap di sana gitu kemungkinannya. Dan untuk yang ditandai dengan warna hitam itu merupakan metode diagnostik tadi berupa kemungkinan terjauhnya gitu apabila pola sebaran distribusi sampahnya yang diatur terhadap WNH kelas tertentu maupun kecepatan arus tertentu yang berada di kebetulan di wilayah penelitiannya di Muara Gembong. Nah, untuk website genome sendiri tampilannya seperti di bawah. Dan untuk pengolahan datanya sendiri ini dapat dilakukan secara offline. Nah, ini merupakan contoh penggunaan genom mengenai pola distribusi dari oil spill atau tumpahan minyak berdasarkan data time series maupun penggunaan data dari klasifikasi WNH maupun pola arusnya yang dapat dioleh dari software goods tadi. Nah, mungkin apabila ada yang ingin mencoba ataupun tertarik mengenai genom, bisa diakses melalui link di bawahnya. Di link tersebut terdapat pengunduhan dari software genom dan terdapat manual book yang kurang lebih dapat menjelaskan penggunaan dari software genom itu sendiri. Dan mungkin sedikit menjelaskan mengenai HiCom, karena sebelumnya dapat kematerian mengenai pengunduhan data di HiCom. Untuk alamat website yang digunakannya merupakan hicom.org. Kemudian kita ke menu data saver, dan karena berkaitan dengan OceanParcels dan kebutuhan tipe jenis datanya merupakan NCSS atau NCDF, kita ke pilihan yang NCSS atau NCDF itu sendiri. Lalu terdapat beberapa pilihan data yang sudah terkumpul yang berdasarkan website ini baru sampai 18 Februari 2020 untuk data yang terbarunya. Namun dapat diakses juga di tahun 2014 tanggal 1 bulan Juli sampai 30 April 2016 yang terlama sesuai dengan dataset time series yang dibutuhkan. Misalkan saya membutuhkan data pada rentang waktu sekian, kemudian kita ke pilihan menu yang handcast data, lalu nantinya akan mengarahkan kita ke beberapa pilihan mengenai tipe data yang akan diperoleh. Mungkin saya ke NCDF juga karena berhubungan dengan kebutuhan software dari OceanParcels. Nah, kemudian lalu nanti terdapat beberapa pilihan seperti ini. Sistem ceknya merupakan tergantung kebutuhan data juga sih sebenarnya untuk data yang dibutuhkan, karena memang yang tersedianya pada kisaran waktu segini dan di website ini untuk data salinitas dan SSD saja. Mungkin kita bisa milih dua-duanya ataupun salah satu untuk mempermudah pengunduhannya. Lalu di pilihan kanannya itu nanti terdapat spatial subset atau pemilihan sesuai dengan koordinat yang dibutuhkan, dan terdapat rentang waktu yang dibutuhkan sesuai dengan data awalnya tadi, data file awalnya tadi yang sesuai dengan time seriesnya yang tersedia. Apabila kebutuhan tadi sudah sesuai dengan penelitian ataupun yang dibutuhkan, kita ke menu submit. Nah, kemudian kita tinggal menunggu pengunduhan sampai beres, lalu data yang dibutuhkan dapat dimanfaatkan untuk kebutuhan lebih luas menggunakan software-software terkait. Dan data yang diunduh yang dari website dari HiCom ini merupakan tipe data NC. Sedangkan kalau yang tadi dari PODC itu merupakan tipe data Excel yang kurang lebih penggunaannya untuk beberapa software yang umumnya digunakan untuk pemanfaatan dari Oceanographic itu membutuhkan tipe data yang NC. Mungkin itu saja yang dapat disampaikan. Terima kasih atas perhatiannya. Saya kembali kepada moderator.
Baik, itu dia pemaparan materi dari Pak Kemaal. Terima kasih Pak Kemaal. Selanjutnya, sebelum menutup acara hari ini, saya akan menyampaikan beberapa hal dari panitia. Yang pertama, mungkin bisa Yang pertama, untuk teman-teman partisipan, baik online maupun offline, untuk mengisi daftar hadir hari ini, sebentar. Oh ya, tolong untuk yang nanti linknya akan dikirimkan di grup WhatsApp. Selanjutnya, untuk seluruh partisipan akan diberikan sertifikat digital. Dan bagi yang membutuhkan hard copy, sertifikatnya, silakan untuk langsung menghubungi panitia. Mungkin nanti bisa langsung chat di grup atau bisa ke via Adel. Selanjutnya, pengumuman yang selanjutnya adalah untuk peserta offline, mangga diambil dari panitia, disediakan vitamin C. Dan jangan lupa untuk semua partisipan, baik online maupun offline, untuk selalu aktif dalam kegiatan workshop ini, karena di akhir acara akan dipilih satu orang sebagai best presenter, dan kemudian juga akan dipilih juga best partisipan. Di mana nanti akan best partisipan dan best presenter ini akan diberikan hadiah yang menarik dari pihak panitia. Untuk kriteria menjadi best partisipan dan best presenter tentunya adalah harus aktif dalam kegiatan workshop, dan untuk best presenter nanti di hari kedua itu nanti akan dijelaskan tentang independent project. Jadi nanti untuk best presenter adalah partisipan yang terbaik dalam mempresentasikan hasil proyeknya di akhir acara. Summary-nya untuk hari ini yaitu jadi hari ini di workshop ini kita sudah dapat pemaparan materi dari Nia George tentang introduction OceanParcels itself and live coding in Python. Ya, dan kemudian juga dari Pak Kemaal sebagai pembicara kedua. Terima kasih Pak Kemaal yang udah menceritakan, memaparkan tentang website-website apa saja sih yang bisa di-download secara gratis untuk mendapatkan data oceanography. Dan besok untuk rundown besok acaranya itu terdiri dari Nia George juga akan memaparkan pemaparan materi yang pertama untuk besok tentang mengoperasikan dan gimana nge-running si software OceanParcels itu sendiri hingga memvisualisasikan data hasil analisis. Dan setelah itu nanti akan ada pemaparan tentang independent project sebagai salah satu kriteria untuk kegiatan selanjutnya di hari ketiga. Itu saja mungkin untuk hari ini, tapi sebelum teman-teman online partisipan pada live meninggalkan ruangan Zoom, diharapkan untuk membuka dulu open kameranya, dan untuk teman-teman offline bisa ke belakang buat foto bersama di belakang yang ini dekat spanduk banner. Oke, jadi kita foto bersama dulu untuk workshop day 1 ini. Ayo. Untuk teman-teman, oke, ini udah Pak Erik nih, udah siap. Yang lainnya apakah sudah siap? Say hello dulu mungkin ya. Terima kasih untuk Pak Muhammad dari Carbon Ethic. Kemudian juga sambil menyiapkan settingan foto, mungkin disapa mungkin satu-satu ya. Selamat berarti yang paling jauh dari Morotai kah? Dari Shark Diving Indonesia, Pak Eko. Selamat sore. Salam untuk Pak Darmawan ya. Silakan untuk membuka open kamera. Membuka kameranya maksud saya. Untuk teman-teman yang lain yang belum, ayo. Ya, di situ. Untuk yang offline partisipan segera Ya, ini Pak Eko ya dari Shark Diving Indonesia. Salam Pak buat Pak Darmawan dari saya Sanny Utami.
Ya Mbak, nanti saya salamkan Mbak.
Oke, karena saya sebaiknya online saja ya ikut fotonya. Untuk teman-teman yang lain dari Unpad, dari Pak Mario mungkin umroh Universitas Umrah. Teman-teman semua kita buka. Oh ya, saya juga kenal nih. Halo dari IPB, Muhammad Gilang.
Halo Teh Sanny.
Ya, halo Gilang. Kenapa nggak offline aja ya? Oke, ke sini. Untuk teman-teman yang lain. Oke, kayaknya udah pada ini ya. Boleh ada di depan nggak? Untuk pakai mouse mungkin harus di juga. Oh oke, udah nggak apa-apa Pak Mario. Oh mati listrik. Oke, semoga listrik cepat nyala lagi biar bisa beraktivitas lebih produktif. Oke Pak Mario. Buat teman-teman yang lain berarti udah semua ya. Aba-aba dari saya mungkin mulai 1, 2, 3. Oh ya, saya di mana ya? Oh ya. Oke, diulang lagi ya. 1, 2, 3. Yang open? Jangan. Oh, nggak usah. Oke, bergaya tangan aja ya, biar lebih semangat. Oh iya belum. Oke, ini buat screen selanjutnya ya, foto ulang. 1, 2, 3. Iya, bagus, keren banget dari Bapak Pusidrosal, gayanya keren banget. Semangat Pak. Oke, udah ini udah. Oke, terima kasih untuk dengan berakhirnya foto bersama. Terima kasih sudah mengikuti kegiatan ini. Sampai jumpa besok jam 1 siang ya. Wabillahi taufiq. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.